So this naming of molecular and ionic compounds, we are actually, it's kind of sounds rough, but we are going to have to learn to talk in Greek to answer some of these questions, to name some of these compounds. But actually, some of the names might seem really long, like this title of that committee, but they are pretty succinct, and they do get to the point. So we might as well get started. Let's start with naming. Give the names and formulas, how to name them, of single atom ions. Like if I have a carbon atom, just a carbon atom, that's how you should write it, just C. And it has, well, I use a periodic table. It has 6 protons in it, right, because the blue 6 has 6 protons. That means it should have how many electrons? 6, right, because 6 positive protons, 6 negative electrons. Whole thing's added to be 0. And we never write, we should, right, 0. You should write a 0 charge on everything, but we never do. Neutral stuff, we just lift it off, okay? But to make carbon an ion, or hey, what has to happen? What changes? Yeah, how do you make carbon an ion? Or any atom an ion? What's an ion? It no longer is the charge 0. It's a charge now. It's negative something, negative 2, or it's positive 6, or it's a number. It's not 0. So how do you make it a charge? How do you make it positive or negative? Change the number of electrons, not protons. Change the number of protons, right? You're going to change that. You're doing nuclear chemistry. You're doing explosions, right? It ain't going to happen. So you change the number of electrons. If you give it too many electrons, it has a negative charge. You take electrons away, it's going to have a positive charge. And that's more than you need to know, but I think it helps, right? Okay. So what is an ion? It's just, a charged particle. Charged particle. Okay. What are the metals on the periodic table? Pretty much the whole darn thing is metals, right? Just stop at that, right? There's the metals. Yeah, hydrogen's kind of off on its own. Good point off here. I like the periodic table that hydrogen kind of a separate little box. It acts like a metal when it wants to. So hydrogen's kind of, so I'm just including it with the metals. It really doesn't. It really belongs off on its own. Okay. The non-metals, right? Everything else here. There's my non-metals. Now it's really going to helpful to use this periodic table as much as we can for naming, because we have it accessible. As long as Dulce doesn't wear her T-shirt that has all the names and stuff on it, right? But anyway, we're fine. So we're going to use the periodic table for everything that we can use it for. So when it comes to ions, metals always form positively charged ions. These guys are always positive. And they're called, does anybody know? Cations. Non-metals, always negative. Anions. Okay. So instead of saying negatively charged ion, we're just going to call them anions. So let's get started naming these cations. The metals, right? The metals. Group 1A, that's right here. Right? Do you remember the groups with an A on them were called the main groups? And their charge was fixed when it comes to ions. So all these guys are going to have fixed charges, 1A and 2A. 1A can only have a charge of +1. Okay. For example, sodium. We call it Na +1. Or you could just write it as Na+. A lot of people leave the +1 out. And you name them, you name that sodium, and this one, you would think you'd call it sodium 1, but you don't, because it can only be 1. So they just call it sodium. All right? So all those elements in group 1, +1, right? Group 2 can only have a charge of probably what, everybody? +2. So magnesium would be Mg +2. So whether this is magnesium and this is magnesium, they have the exact same name because it has no choice. It has to be +2. Okay. Group B elements. Okay, here's all that. Yeah, exactly, Oscar, the transition stuff. Right? That stuff, the B elements. Right? You give the name and a charge in parentheses. Iron 3. So that would be iron and a 3. Right? Copper 2 would be a copper and a +2, for example. So you just give the name and the charge in parentheses for all these group B metals. Now remember, they're all positive because they're all metals. They're all metals. There's one more cation left. We just got to know him. He's the first polyatomic. Polyatomic ion meaning more than one type of atom, right? Like you have a nitrogen bound to 4 hydrogens. The overall charge is a plus. You just have to know the name and the formula for it. Okay. The anions. Okay, now if we're talking about the anions, we're talking about this stuff over here, right? The nonmetals. They're all negative. They're all anions. And how do you, so the nonmetals form anions, charge of 8 minus the group number. There's kind of an easier way to do it, but that's okay. But add an IDE to the stem of the element. So for example, if you have F, it's called fluorine, it'd be called fluoride if you make it a negative. How do you write fluoride? F-L-U-O-R-I-D-E. Now how did I know just to put a minus on there? You can always take 8 minus the group number, but I think it's easier to just count over to the noble gases. So for all these halogens, I count over 1, -1. The group that oxygen and sulfur are in, they'd be a -2. Carbon would have a -4, right? Just count over to the noble gases. And they're all negative because they're all nonmetals, right? It sounds weird that carbon would have a -4, but it does. And you don't call it carbon, you call it carbide, right? That IDE you have to add to the end. Carbide. What would S-2 be called? Sulfide. Okay, that's the game we're playing. So that takes care of a lot of ions, but there's some left. This table of polyatomic ions, okay? And I'm just going to cross, there's 2 ways to write the acetate ion, right? See how there's 2 carbons, 3 hydrogens, and 2 oxygens? You could also write it this way. 2 carbons, 3 hydrogens, 2 oxygens. But let's just, everyone write it the same way. I think life will be easier. So when we write acetate, we'll write it as C2H3O2 with a negative charge. So we need to know the names and formulas of all these polyatomic ions. They're all negative, except for ammonium. If you've ever memorized a nice big group of things, there's an easy way and there's a hard way. There's a more efficient way, put it that way. None of it's easy. The most efficient way. If you don't want, here's one way. You just put a piece of paper over it, acetate, C2H3O2 negative. Oh, I got it right. Ammonium, NH4 plus. Oh, I got it right. Carbonate, CO, I forgot. Okay, so then what you do is you go back to the very top. Do it all again, right? And then you hit carbonate and hopefully you get it the next time. But wherever you screw up, go back to the very top again. Okay? Flashcards. You want to make flashcards? Great. Right? NH4 plus. Got it. Right? Carbonate, CO3 negative 2. Got it. Ah, screwed up. The ones you got right, put them on the top, do it all again. Okay? You're going to get it done the fastest. It sounds like work, but the psychologist guys, they say that's the way to do it. So, and it does work. That's firsthand, I'll tell you. Okay. Let's get this back down where it belongs. So naming ionic compounds. So now we're going to name the actual compounds. We're going to have the cation followed by the name of the anion. So we're going to name the cation and then the anion. Like this compound. We have a cation followed by the anion. So here they gave us the name. We just have to give the formula. So calcium, we know that's Ca. And chloride, well, that'd be the Cl. But what are those little numbers on the bottom? The calcium is a +2, right? Notice how there's a hint to know where to look, because it's always cation first. It's not calcium 3 or calcium 4. There's no number. There's no Roman numeral. So it has to be in group 1 or 2. So you look for it. Oh, it's in group 2. So I put a +2 up here. And the chloride, you go over and you just count to the noble gases. It would have a -1, right? Because you just count 1 over. Boom, I'm there. So just 1, -1. Now, do you see the problem? Compounds can't have a charge. They have to be neutral. This calcium has a +2. Chloride has a -1. The overall is a +1 charge here. That ain't going to work. Like, stuff isn't electrical. It's all neutral. So put 2 for the chloride, yeah. Put 2 of those. Now, you don't even really have to think about this stuff if you do the whole diagonal game, right? Put this charge down here. Put this charge down there. It works every single time, all right? So I'm going to have 1 calcium at a +2, 2 chlorides at a -1, so -2 and a +2 overall, 0. You can leave it like this, or you can clean it up. All right, it's all, I'll accept either way. Okay. So an easy way to identify that you're naming an ionic compound, and the rule is name the cation, name the anion, you have to see a metal. Because metals are always positive. If you see a metal, dang, I got to figure out what that cation is, I got to figure out what that anion is. If you ever see a metal. And remember, those metals are pretty much the whole darn periodic table. You ever see one of those? You half name the cation, half name the anion. If you're not sure what it is, I bet you it's one of these. So you got to know them, those polyatomic ions. Okay. There's only one other game in town, and that's naming molecular compounds. There's no metal present. All you have are 2 of those. 2 nonmetals stuck together. How do you name it? Well, how do you count to 10 in Greek? That's what we're going to have to do. We're going to name, like, look at these down here in the example. You've got sulfur and oxygen, phosphorus and oxygen. Right? There's no metals here to be seen at all. They're all nonmetals. So you name the first element, and then you name the second element, but add IDE to it. And you're not quite there yet. You have to use Greek prefixes to tell the number of elements that are there. So before we can even do that, we got to count to 10 in Greek to know these prefixes. And I think the only time you've probably seen this is if you were in geometry. What's 1 for Greek? In Greek, how do you say it? Mono. Okay, mono. How about 2? Di. 3. Tri. 4. So there's the T. Tetra. Okay, now 5, that gon. Pentagon. 6. Someone said hexa. Hexa. 7. Has a P in it. That's a good, yeah, what is septa? It's hepta, but what is septa? Septa is something, isn't it? I've heard of that. Oh, in Spanish it's septa? Really? Okay. Hepta. Well, that has to be Greek. It doesn't count. What's 8? Octa. If you know 9, you're doing really good. Nana. Very good, Oscar. 10. Deca. So you got to know how to count to 10 in Greek. And then none of this is too bad, right? Because we know we have how many sulfurs? 1, so you have to write mono. And it's sulfur, so you write sulfur. How many oxygens do you have? 2, so you have to write di. And oxide, not oxygen. Very good. You have to add IDE to the last one. Right. How about this one here, this phosphorus daisy? How would you name this P405? Because we can't go around saying P405. We're supposed to say, what's that? Tetra. Ooh, good. Tetraphosphorus. Pentaoxide. Nothing wrong with this, right? This is good, except some people like their own little way of doing it. They don't like 2 vowels. So some people might, and this, how this is written is fine. I just want to show you the other ways. You might see this, showing that the A is optional. Or some people might just get rid of that A altogether. Pentoxide. Tetraphosphorus pentoxide. What's the technical way to write water? The technical way, actually the way you're supposed to write water. What the heck happened here? Let's pick on Danielle. Got these all messed up now. Danielle, how would you write the technical way of writing water? Dihydrogen. Good. There's not 2 oxygens, though. Dihydrogen. Monoxide. Yep, dihydrogen monoxide. Okay. Sometimes they leave the monos out, but I just always put them in. Life is easier that way. So there's 2 games in town. Either you have to count to 10 in Greek and name these compounds, right? Name the first element and the second element at IDE. Use the Greek prefixes to tell you the number of those elements. But you only play this game if you don't see a what? A metal. You don't see a metal? Yeah, there's nothing there to create positive and negative. But if you do see a metal, just name the cation and then the anion. Okay? So there's a lot we're going to have to be knowing here. We need to know the names and symbols of elements in all the first 4 periods of the periodic table, right? Maybe even more after a while here. The names and formulas of the polyatomic ions. That's that stuff in this table. Know how to name ionic compounds. So you recognize it as an ionic compound because it has a metal, and just name the cation, then the anion. How to name molecular compounds. No metal present. There's no metal present. So count to 10 in Greek. Name the first element, the second element at IDE. Naming is going to be on every quiz up to the first exam. Yeah. Okay. Let's try some of these here. Danielle. Jorge, how would you name this first one? It's just K. K was, there's the P, potassium. K plus, Alejandro. K plus. How would you name that? Oh, that ion. Would you help them? It's potassium. It's the exact same thing again, right? Exact same thing again. Potassium. Why isn't it potassium 1? Yeah, it's always in group 1. Anything in group 1, they have no choice. So you don't say anything. And remember the IDE, like the IDE stuff, that's all negative. Those are all anions, right? Like O-2 is oxide. Okay. So these cations, either you don't give the Roman numeral, group 1 or 2, or you do give the Roman numeral, transition metal. Okay. Ca, Melissa. Calcium. Ca plus 2. Annabelle. No, IDE is always negative charges. This is a positive charge. Just calcium again. And you don't say calcium 2 because it's in group 2. It's just calcium again. All right. So this IDE stuff that I think you guys are confused on, where's that anion stuff? Here it is. That's this. Nonmetals. That's nonmetals. Right? IDE is anions, nonmetals. I negative. Oscar. Iodide. Very good. Right? It was iodine, but you're supposed to call it iodide. Have an IDE on the end. And it's only a -1 because they counted over 1 to the nobles. That's how they got it. Christian. Copper. Number 7. Diana. Copper with a Roman numeral 2. And it has to be Roman numerals. It's going to happen sooner or later. How do you write a 4? Oh, back up. How do you write 5 in Roman numerals? V. How do you write 6? V1. All right. Now you know the one I'm going to ask. How do you write 4? 1V. All right. The rest are just okay. Number 8. Jonathan. Perfect. Nickel with the Roman numeral 2. And these are trick questions. 9 and 10 are trick questions. And Dulcie, I'll give you a hint. These guys have no choice. Aluminum has to be a +3. Zinc has to be a +2. Kind of like calcium has to be a +2. Sodium has to be a +1. Right, aluminum, zinc are way over in here in those transition metals. They're the only ones that don't have a choice. So it's just aluminum. Good. And the Zn +2 is going to be zinc. Good. Anytime they're in this group, group B, except for aluminum and zinc. All right? Anytime they're in those transition metals, you add the Roman numeral in parentheses. How about 11? Erica. AG. It's worth a lot of money. Not gold. Gold is AU. Silver. Okay, you're close. It's in the group B stuff. What was that? Roman numeral 1. Yeah, it's just a plus. I don't know why they leave the 1s off, but that's fine, right? Just understood. Tegan, 12. Perfect. Everyone sees how she got the -2, right? One hint is the IDE. So you know it's got to be negative. And where's the negative stuff? Your eyes should definitely be going way over on the end of the periodic table. And then she counted over to the nobles from S. 1, 2. But you got the negative 2. Very good. Daisy. O negative 2. Good. Danielle, I think all the easy ones are gone. Carbonate. We're going to have to cheat and look at that table, I think, unless someone's got a shirt with all this stuff on it. C what? No. Where is it? Here it is. So it has to be this. CO3 with a negative 2. You see that? It has to be that one. Carbonate is CO3 with a negative 2. So we just have to memorize the names and formulas. Jorge, 15. Sulfate. Now we're starting to name compounds. Because look at this, Alejandro. There's no charges here. This is a complete compound. So Alejandro, before you give, I don't want you to give an answer. Instead, what I want you to tell me is, what game do you play to answer this question, to name it? Do you play the game where you name the cation and the anion, or do you play the Greek prefix game? Cation, anion. Why? Because there's calcium. Exactly. So Alejandro was exactly right. You got to name the cation, Melissa, and then the anion. Yeah, you're just naming it. Name the cation and then name the anion, and you're done. Oh, what's Ca? Calcium. Hydroxide. Very good. So all you're doing is naming the cation and the anion. And if it helps you, write the cation, right? That Ca, you don't even have to use the periodic table for this. Use the formula. Ca has to be a +2 because that 2 goes over here. The hydroxide has to be a -1 because it's always a cation first, then the anion. This has to be a +2, right? Because that's a 1 right there. That has to be a -1. So you're looking, you have to name this, and you have to name this. Calcium hydroxide. You don't care how many are there at all. There's no Greek prefix monodi stuff. All you do is name the cation, name the anion. Calcium phosphate. Calcium phosphate. Annabelle, what should you write for calcium phosphate? You want the formula now. Ca. Yeah. And how many O's? 4. Okay, we're really close. Let's put the, that's the calcium and that's the phosphate. But we need the number of each. You notice how they have 2 hydroxide. We need to know the numbers of each. If phosphate has a negative, and she just got this from the table, PO4 -3. It's exactly right. What's calcium's charge? It's a 2. Right? I say you just do that transposing thing, right? Put in some parentheses. Put the 2 where? Down the bottom. So you need 2 phosphates for every how many calciums? Move the charge down. 3. And then, I mean, you can always check the math, but you don't need to. This is going to work every single time. 3 times +2 is +6. I have 3 calciums, +6 charge. Each phosphate has a -3, but I've got 2 of them. So -6, +6, 0, it works. Well, all this works. You can write all of this. You can leave the charges in. It doesn't hurt anything. But the cleanest way to do it would be Ca3 PO4 2. Right? Ca3PO42. But I like leaving the charges in. It shows how you got stuff. If you're going to explain to somebody, it's much easier to see. Oscar, we need to give the formula.
Sodium nitrate.
Sodium nitrate. Very good. Okay. Write in the formula for these next four, and I'll ask you as we go along here. Write in the formula for these next four here. Let's see. Not sure, just to ask. Help you out. Copper, all metals are positive. They're always positive. All metals are always positive. And they always name the cation, the positive one, is always named first. Christian, how did you name this number 19? What did you say? K. CO. Carbonate should be CO3. But -2 though.
Yeah, that's what I'm
Okay. Final answer? The K has what charge? Positive, right? A +1, right? So the 1 will go here, but that 2 has to go down there. So you should have K2CO3. Right? So I like putting those charges in because they tell you what to make stuff. Yes. Yeah, you can. People a lot of times they don't write the ones. Right? And it needs to be outside the parenthesis because whatever you write down here, that's how many of you have inside the parenthesis. But a lot of times people, like even the K+, people don't write the 1. They should write a +1. But copper 2 sulfate. Diana, what did you write for that one? Cu +2 for that one. And 4, right? Okay. Good. 2 goes down here. 2 goes down the other side. Okay. Just one last thing. I hate adding these things to it. But when you have molecular compounds like water, H2O, those subscripts are exact. For ionic compounds, all that's holding it together is a cation and an anion. And they're just crystals. They're the simplest ratio. They're not molecules flying around. You don't have this thing flying around. It's actually a crystal, solid. So these are always the simplest ratio for ionic compounds. So you have 2 coppers for every 2 sulfates. Well, it's easier to say you have 1 copper for every 1 sulfate. The simplest ratio. So they're going to get rid of those 2's. And I don't think there's any more trick questions now. I think you got them all. Get rid of it. There it goes. Okay? Yes, it only works when they're the same. Or no, I guess you could have a 4 and a 2. Then you divide it through by 2. Then you'd have a 1 and a 2. Right? Because that'd be the simplest ratio. But you're right, Daisy. It's pretty much going to be only when they're the same. Jonathan, did you get 21? Cu. Cl. 2. Good. Right? Because it's copper plus 2. Chloride with a negative 1. CuCl2. Calcium oxide. Dulce, did you get calcium oxide? Ca with a 2 and O with a negative 2, right? So you ended up Ca2O2. But now that we know about the simplest ratio thing, it would just be anybody, just be CaO. All right, let's jump down to these guys. 24. P is phosphorus. Now remember, do you see metals? No, there's no metals here. So that means you have to name the first element, name the second element, add IDE, do the whole Greek thing. Yes, it'd be monophosphorus. Yep. Some people leave the mono out, but I always go through all that work, you might as well leave it in. Erica, how did you name 24? Monophosphorus. But 4 is tetra.
Oh,
Trichloride. Very good. Everybody, how about 25? Dinitrogen oxide or dinitrogen monoxide? That'll work. 26? Nitrogen dioxide or mononitrogen dioxide? Very good. Okay, so the name of the game is just to identify, right? Do you see a metal? If you see a metal, name the cation, then the anion. If you don't see a metal, name the element, name the second element, add IDE, and use this monodi-tri stuff. Okay. So for lab, know as well as you can, right? These polyatomic ions will make your life a lot easier. So have a good day. Come by if you have some questions. Glad to help you out.